Hello and welcome to the final part for the biome generation. So we've put together a bunch of things for generating the biomes, generating the height map, the terrain distortions from that, then texturing it, and then finally spawning different objects there. So what I want to do now is actually start to do a bit of cleanup. Because that's something where, as we were going through, there was a few things that we set up as shortcuts to be able to test things, to get things up and running, and we want to try and now fix those up and make it so we have some more robust ways of working with things. So one of the things we did was with the texture setup. We had to actually make sure we had this text matching up exactly then with text that was here in the biomes. So that was a lot of extra setup. We're having to set up information in two locations. We're having to make sure names match perfectly. And that's a big potential for errors there. So that's actually the first thing that I want to target from a fixing point of view, is making it so that we're not actually needing to have this process of making sure these text labels match. So what I'm going to do is, and we're going to do these changes in a couple of stages, and part of what this is going to demonstrate is ways you can approach refactoring code. Because refactoring code is something that we're going to need to do at times, and in particular if we're implementing something new. This is a really critical thing. The first time we're implementing something, and even actually the first few times we're implementing something, we're going to have a less optimal version. It's not going to be typically as good in performance as it could be. It's not going to be as easily maintainable, as easy to work with as it could be. And that's okay. That's actually a natural part of the process the first few times we develop stuff. And that's why it can be good to come back and refactor things to be able to improve it. So the texture painting is one of the big ones that I want to improve. So I want to actually make it that on these texture painters, I want to, rather than configuring strings, I want to actually be able to directly link in the textures. So I want to be able to have my terrain textures. So this is going to cause the code to break. And we'll see, when I go back to Unity, there's going to be errors, and that's intentional. I actually want to break the code because by breaking the code, that's going to then make it very clear what areas I need to fix. So this is going to be able to have a list of textures. This one, it's going to change to just a texture 2D. And then the random one is fine. The smoothing one I've already set up. That doesn't actually need any changes. So I've got these two, and these are now going to be broken, which is fine. That's what I want. Because what I also want to then do is the biomes. I don't want to be configuring the textures on the actual biomes. So a biome object here where I could configure these individual textures, I actually want to not be doing that. And I can see that I've got a diffuse and a normal map. So I'm going to bring this to the side here, because what I will do is the base texture painter, which I'm also going to bring over here, I am going to take this biome texture object and bring this over here. I'm going to get rid of the unique ID, and I'm going to go and call this a texture config, or texture config works. And so then what I will do is actually in these ones for painting, I'm going to have these be a texture config. So I want to then, my biome is actually going to lose this list of textures. Again, this is going to cause stuff to break. It's going to cause stuff to fail to work, which is fine. I actually want it to fail to work because one of the approaches I will often use for refactoring things is I will intentionally make the code break so that then I have to go back and fix up the different areas. It's a good way to identify all of the areas where I need to actually make changes to the code. So I will intentionally break it. And at this stage, I'm still very much at the breaking stage of things. Which is what I am after. Because I've broken things like the biome config, and I should also have broken the procgen manager as well, which was the goal. So procgen manager will be broken and likely in a couple of spots. So one of the first things where it's broken is this idea of generating the texture maps. So that's something where, because in our actual painters, I need to be able to say, hey, well, what's the texture for this the entry into the stack of alpha maps? I need to find that index. So okay, that's all good though. I can work with that. So I know that one's broken, and the other part that should be broken is generating these layers. Because what I was doing before was I was asking the biomes for the textures. And so that was great, but it could mean cases where if the same texture is used, that I was creating multiple layers that had the exact same content. So I can actually improve upon that and mean that I'm creating less layers, which is going to be good. So from the biome config, I'm going to get rid of that variable. And what I want to be able to do is I want to, from each biome, I want to get the set of those texture objects. Because what I want to do is I want to put together a unique set of texture objects. So if I've already got a particular texture registered, I don't want to re-register it again. So what I can do, so I'm already looping through my biomes here, and I was looping through the textures. So I could have a setup here where what it's doing is I want it to return a list of, and I believe, what did I call it? A texture config. So I want to retrieve a list of texture config objects. So the idea of what I'm going for here is I will ask each biome for its particular set of textures. So I want to get the texture config and retrieve textures. Now, I've got a couple of different ways of how I could build together this list. So one of the simplest options for doing this, my texture configs, all textures, set up a new list. And then what I could do here is on my, so F terrain painter, it's not null. Then what I would do is terrain painter, get components. So I'm retrieving all of those texture painters on the particular object. So I retrieve my base texture painter. So this is going to give me painter. And this is my painters. So then that base texture painter, well, I probably need a function on it that is able to return the list of textures there. So I can have this, so texture config, retrieve textures, and I make it return null by default. So this, and say, oops, not void, virtual, because what I can do is in the individual painters then, I can choose to override this. So in the case of this one, it would be a new list texture config, and I can actually, I'm not getting autocomplete at the moment. So this does happen at times where autocomplete will mess up and not be working. So what I'm briefly going to do is attempt to fix the autocomplete, which I find often when that happens, and it could be because I updated Unity version. So often when that happens, deleting the project files can actually sort out the autocomplete issue and then reopening it. It could also be being caused by the errors that are being encountered. That is also the case of what can happen. But okay, it's probably detecting the errors now, which is good. Much better. So I can override this, so I can return my new list, and I think there was a version, no, it can take other collections, so list texture config, textures, textures add. Now this is not a thing I'm commonly needing to do, so this is an amazing performance, but it's not a common task I'm needing to do, so it's not too bad an issue. And then in random one is easier. I can just return that list of ones. So that's good. We've got that able to retrieve ones. This is going to return all textures, and I'm just going to move the initialization into here, just because I want to be following a pattern where if there's none, it returns null, because that's been something I've been fairly consistent with so far. So actually what I would do is fterrain painter is equal to null, and just return null. That's a better setup for it. So where possible, I'd like to try and structure things like this, where the code doesn't nest to too much of a level. I prefer to do things like this of just earlying out if there's no terrain painter. So this will, I've got my list, I've got this, so that's good. Then painter in all painters, and then all textures, add range, and I should then be able to say painter get retrieve textures. But that could be null. So what I might do is set up a thing of if painter has textures. Actually, no, what I'll do is I'll store, that would be needing to do extra calls. What I'll do is this, if painter textures, that, painter textures, and then here, again, avoiding if that's null or if painter textures count 0, then let's continue. So this is just a general preference in terms of how I like to structure my code, that I like to do this approach of I early out and avoid nesting. I find is it avoids the code getting sort of too deep in terms of structure, and it makes it just a little bit easier to actually follow it. So extract all textures, on every painter. So our biomes have a way of giving us back all of the textures now, so that's good. So from each biome, I can now say biome retrieve textures. So list, and this is my list of texture config. So this is the biome textures. So that's good. I've got that. But I want to then pull this into a single list. So then what I want to do is actually something like this, where I have similar thing of list texture config all textures is a new list of texture configs, and similar to what I was doing with this. So I'm going to look at that. And again, if biome textures is null or biome textures count as 0, then I skip. And then all textures add range, biome textures. So this is building up the build-up list of all textures. Now there will currently be duplicates here. This would still give us duplicate entries with this, which we already identified that we really don't want to have duplicate entries. So what I would be able to do then is, this is where something like link can be handy. Because I could have duplicates here, so I would potentially need to do filtering here and filtering in this location as well. And I don't want to do multiple rounds of filtering. That's a little bit redundant. So what I can do, though, is all textures. And then, so we have a bunch of queries that we can do with link. And one of the handy ones is we can use this one distinct. So all textures, so if I do all textures equals all textures distinct to list, what that will do is distinct gives me only the unique ones. So filter out any duplicate entries. So that's good. Now, what I would likely need to do, though, is in my base texture config, I would need to give this a way of comparing two texture configs, because essentially, if they have the same diffuse and normal map, they should be treated the same. Now, at the moment, without having done anything extra, what would happen is it would be would just be comparing the actual reference to the class. It's not comparing the content of the class. So I would want to set up some stuff to make it that it is actually comparing with the content of the class. Now, if you're using Visual Studio, not Visual Studio Code, there is actually shortcuts that will do that logic for you, that will override the will generate those comparison bits of code for you. Now, those bits of refactoring don't actually exist in Visual Studio Code. We don't have versions of that, and I don't think there is an add-on that currently adds that. So we need to actually manually set up the comparisons here. So we'll take a look at what we need to set up for that, and then we'll be able to build from there. So to set these up, I am just referring to stuff that I'll check the reference for. So what we are saying is, we'll likely need to grab this from system equatable, so that it's something that we can be doing equating with. So we are doing an equatable with texture config. So we're saying it implements this interface, and so it immediately gets a little cranky at us, which is fine, it should. because it's telling us that there's methods we haven't implemented. So what we have to set up is an override for equals. So this one is the one where it's just checking against any generic object. So usually what we end up doing for this is, we'll see in a moment, is we next then have a type specific one, where what we are passing in is another texture config, which I use for the general convention of other. So what we usually would say is, okay, well, the other has to not be equal to null, because this code could only run on us if we are not null. So if the other thing is null, then there's no chance of it being able to be equal. So if the other is not null, and if the other's diffuse is equal to R diffuse, and if the other's normal map is equal to R normal map, then that means that it has to be equal. We can then also here, we can say, okay, well, equals, and then we do other as texture config. I'm going to rename that to other. Because if other happens to not match the type, then that casting will make it null. The other final thing then we need is this public override int get hashcode, which with that, well, we've got two objects here. And so if we go diffuse, it has a get hashcode on it. So these things do have a get hashcode on them, but we need to merge those. So we can say, because there is a hashcode combine function. So hashcode, which I'll need to track down where that is actually in, because it's not one that I've actually seen before. That's actually really handy. So there should be a system hashcode dot combine, and I should be able to say diffuse get hashcode and normal map dot get hashcode. Now it seems to be not recognizing it, which what that might be is that the Unity runtime is referring to a different version of the .NET framework. That is very likely a possibility there. And we can actually change that. So that's something where, yeah, we can absolutely be running into that. And that does look like that is the case, that it doesn't recognize the hashcode combine. It's not giving us an error on it in this though, so we might leave it and see if we, actually no, I didn't save it, so it wouldn't be picking that up. So there isn't a hashcode combine in the default version that it actually has. So what I could try, it's under project settings, so we can actually change the scripting runtime that we're using, and it does often default to the 2.0. Can actually upgrade, so we can switch over to the 4.x runtime. It does add some new functionality there in the .NET language that we don't always have, and we can see with that it may still be the case that it doesn't actually have that one. So it looks like that's one that has not been implemented yet in Unity. So unfortunately, as we found there, system hashcode is not yet available in Unity, even with changing the API to the latest version. So that is a thing that we do run into at times, that there are newer features in the language that are not always there and across. And so this is unfortunately one of the ones. It's unfortunate that it happens to be a really handy one as well. So we can go for a more basic way. Definitely, this is something where keep an eye and see if system hashcode is there and available. As soon as it becomes available, I would be recommending using it as best practice. Until then, this is not a mission critical thing. Nothing's going to go too wrong if it doesn't sort of hash correctly. But what we can do is, okay, it's our hash. You might notice there's hefty use of prime numbers here. That's an intentional thing. Get hashcode, and then hash again, array plus normal map, get hashcode. And then we can return that hash. Not ideal. This would definitely not be my preferred method. I would much prefer for there to be a access to the combine. Unfortunately, it's not there yet, so we have to work around it. So get hashcode, that'll mean the ones can be compared properly and efficiently, so that then when it's working out the distinct list, that is actually able to be handled really quickly, and that it can build that up effectively. So we've got our set of entries, so that's good. Now we know that we do have our setup for generating this mapping. So what I might actually do is I will update it as well, but I'm going to actually take this and I'm going to update this texture mapping first, because what I want to do is bring the line to make that distinct up as well, so that what I can do here, just so the logic is consistent. So this will generate the texture mapping, so it generates our dictionary of all of the entries. So we've generated our unique list. So then this, what I would say is, rather than iterating over all the biomes, we're iterating over the texture configs. So it would be for each var texture config in a filtered list of ones, and then we would have biome texture to terrain layer index. So this, the key would now be our texture config is equal to the layer index, and we update the layer index. So that's good. So our dictionary is actually changing in structure here. So if we go to this, rather than that being a string, it's actually going to be a texture config. So again, going this principle of making the changes actually provoke errors, so that we then go and we fix those errors to get everything all properly set up. Because what I would then do here is I would actually generate texture mapping. So I'd run this, build, because that I know will have populated a dictionary. Because what I get from running this is I get a dictionary and a layer index. So this, before it was possible to, we could have a few sort of mismatches there, less than ideal. What I want to be able to do now is I can have things match exactly. So, okay, I've got my dictionary that has my texture config, and it has my layer index, so that's good. From that dictionary, I can extract those two things as arrays, so I can get all the keys, I can get all the values there from it. Because I don't want to iterate through the keys, because that won't necessarily give me the correct index layer-wise. Although, what I could do is I know the exact number of layers I'm going to have, because I have built up this. So I could be saying here, okay, num layers is equal to that dot count, which this will let me then pre-allocate that. So this is going to generate all of the layers. So then, because I've pre-allocated for a set of stuff there, I could pre-allocate the layers. So what I could do is layer index 0, layer index is less than num layers. This, and then in here what I would be saying is, okay, well, new layers, layer index, actually no, sorry, new layers, add, and then I add in a new terrain layer. So I'm just pre-allocating all of the entries, and then iterate over the texture map. So in this case, before each, and then this would be the texture mapping entry in my biome texture. So this, when I iterate over a dictionary like this, what I have is my texture mapping entry, the key. So this is going to be the texture config. It's equal to that. And the texture layer is going to be the value. So this gives me entries that I can then directly control, because then what I can say is, okay, well, texture layer, diffuse texture, whoops, texture mapping, sorry, new layers, texture layer, diffuse texture is equal to my texture configs diffuse, the new layers texture layer normal map is equal to my texture configs normal map, so I can configure my texture. Terrain layer textures. Then I can save this. So I need to save this new layer as an asset, which we'll get to naming that in a moment. And then it means I can get rid of this code. So the actual texture layer, I'm going to change that to texture layer index, because I think that's a better naming for it. Because then I could say texture layer is new layers, texture layer index, which that makes for clearer code. Got those. But I need to get the name for this. So I'm going to change the naming process for these a little bit, in that I'm going to bring in the index here. So it's going to be layer, and we'll have that. And I will probably, because we don't need to often refer to these layers, I'll get rid of the actual bit where it was putting in any text from it. So okay, that will generate my texture layers now using the new process. Now, there will still be things where it's grumpy with us. One of the ones being, we had stuff here, get layer for texture. So this now needs to take in a texture config. Config. So we can change that here. So that means we've got less errors, and this is the process. We we go through this step by step, we end up with progressively less and less errors. Because here, where this was doing get layer for texture, that just changes to that. And then the one for the random, then, well, we're picking a random one from this. That changes, and the rest is the same. So if we head back to Unity and make sure we're done with errors, what we'll see is we've now got a cleaner setup. So in our biomes, we're not configuring the textures there. And then if we go to our terrain painters, then, okay, well, the random one, we can actually just start to directly add in our textures. So this is for bush. So let's make it have dirt and rock. So it means we're configuring them just in the spot where they're getting used, which is going to mean less potential errors. We're not having to type stuff in or link stuff up that's getting set up in other areas. When we're configuring texture painting, we configure the actual textures at that point. It's a better way of setting it up. So Grassy Plains, we obviously want grass, and we might say with Grassy Plains that we can also get mud. For rainforest, so rainforest had the slope painting set up. So what we want to do is for the diffuse, let's go for fairly bright grass and then rock. So we can easily check that we've got sort of different setups for these. Grass and mud, rainforest is grass and rock. Scrub, we're going to make it dirt, and let's also chuck in sand. And then swamp can be swamp and mud. So it makes it a lot quicker for setting everything up. Now, what we want to check is that this doesn't then break everything, because that's always a possibility. So we want to check, we had our layers here, and we ended up with a lot of different layers. We would be hoping to end up with we shouldn't get 2 layers per biome. So we've got 5 biomes, so we shouldn't get 10 layers if the comparison checks are working properly with stuff. So let's run our regenerate textures. We didn't get any errors, which is good. Now our terrain's texturing will reset. We do expect that to happen. That is entirely normal. Now we can inspect our terrain and see, okay, we've got each of our textures there as a layer. That looks correct. So that's promising. It's generated those layers. It looks seemingly right. So that means our comparisons have worked properly. So now it's down to whether our actual texturing algorithms are still working. So we'll regenerate the world at this point. And what we're hoping to see is that we're still seeing variations there in the texturing of the environment. And we are. We're still seeing ones, we're seeing things that are keying off of slope. We're still seeing the nice sort of fading between sections, which is good. So the big set of changes that we were making with this is and this is a setup that you can do with things. What we were doing was we made it that the data we're using is configured where we're using it. That's really the big sort of one of cleanup there that we did, was that we made it that when we're configuring these, we are configuring them in the location where they actually are being used. So the thing that's doing the painting has the actual logic for saying here, and has the data for, well, this texture. Makes it really easy to know, okay, well, it's random. I can see visually what I'm actually getting texture-wise. So it makes it a lot easier to set up. So what that means, though, is we then need to pull that data into the areas that are using it. And what we did was we pull that data through the biome. So we're still going through our biome because the biome links to the things doing the painting. So we still pull that information through the biome. The main difference is that what we're doing is that then gets collated in a central point. So we pull all of that data together. We used link to make sure that the data was unique so that we weren't getting duplicates. And that meant that we did have to, in our script, we had to set up our equals functions and our get hashcode one so that we could identify the things. But now this also means that we can reuse textures in different biomes and it won't create additional layers. We actually have less layers than we did before because the same textures are used. And so as a result of that, it doesn't need to create extra layers. So we've thinned down the amount of data that we're storing, which is good. So we've made it easier to work with. So it's a lot quicker to get things set up. We're not having to make sure text is matching or setting up stuff in one spot and then going to another. It's all configured in the one area. And we're also made it that it's using less storage and there's less processing that it needs to do, even down to things like our filtering of the textures at the end to get this nice sort of smooth set of changes with things. We didn't need to do that on as many layers now, so it gives us a bit of a performance gain there as well, which is a big saving. Okay, so the final thing we might add in, because we've got a bunch of cool things we've added in already. Terrain painters, we did have this set up for the post-processing there with those. And what we can do is we already had the terrain post-processing for smoothing. What would be a handy thing is to actually have a texture painting one that is based on height. So texture painter height. Because what this is something I could do then is I could use this to paint in essentially in really high areas. It just uses a snow texture, for example. So there are some ones where if you want sort of common things across all of the biomes, you could do that in your post-processing. So in this case, I'm going to have height threshold. So actually what I could do is start height and then a end height, so it can paint in a bracket. Terrain painter height, and then for end height, and then so that I can control the intensity at any point in that height, I want to have good old animation curve to control that intensity. Because what I would then do is, so this would be grabbing the height at that particular location. So this is where I would need to take my height map, get my height map X, my height map Y. So I need to convert from the 0 to 1 range in the height map to an actual world height range. So what I could do is, and actually what I would probably do is convert the other way. So height map start would be start height divided by height map scale dot y, and height map end would be end height divided by height map scale dot y. The reason for doing this is I do 2 divisions versus doing a multiplication for every single cell. So it can scale down the amount of calculations I need to do. Now, it is a very micro optimization, but it's one that is going to have potential there for at least some benefit. Because what I can do is, okay, well, if the height map height is less than my height map start, And what I'd probably do is pull that height map value out, so I'm not looking it up multiple times. So if the height is less than the start, or the height is greater than height map end, then I just skip it outside of height range. Otherwise, what I would do is I need to get the intensity factor. So I need to work out the percentage that I am between that start and the end. So it'd be height minus height map start. And then I would divide that. And again, this is one I would put up here. Height map range. Height map end minus height map start. And if I really wanted to eliminate every possible thing, or as many as I could do height map range inverse. So if I multiply this by height map range inverse, that's going to give me a 0 to 1 value that I can then say, okay, well, intensity, evaluate for this. So this is going to be my new value, which the strength can go in there. So I'm just modifying the location based upon that curve. So this would let me easily add in snow to this above a particular height. So then what I would set up for this is in the post-processing. Once it's imported the changes. So if I get my texture painter height, now I need to move this up to the top. So it needs to run before the smoothing. Grab the snow. Now start height. This is where we need to work out this. Now I am going to use a really lazy way of doing this, where what I'm going to do is I'm going to make a gigantic plane. Maybe not that gigantic, but like this, because what I can do is, as I move this down, I'm looking for the spot where this starts to just clip against the particular ones. I actually need to make that, 100 seems about right. And that center, I think, should be there. So, okay, let's lower this. So, no, max height seems to be about 60, that looks like. And then if I was making everything snow above that height, maybe a little bit higher, if we went for like 40, that's a little bit. So I could start to kick in at 30, and then below that could change it. And we could do a similar thing for if we were wanting to texture stuff for water as well. That we could, below a certain height, be texturing stuff. So I want to have it start at 30, and I'm going to have it end at 60. So it's only going to apply in that range. And then what I can do is I can just say, I want it to ramp up fairly rapidly. So that looks pretty good. Now I need to regenerate the textures. And because I'm adding in a new texture with this, and let's just make sure I actually configure the texture. I did. So I need to regenerate the textures. So again, the terrain resets. We expect that to happen. That's fine. But when I regenerate the world, we should see that we then, so we do get an issue. So this is one where, and this is actually a great one to have run because we missed something. Generate texture mapping. We ran through the individual biomes, but we didn't check the post-processing one. So F config painting post-processing modifier. Then with it, we need to actually retrieve all of the textures as well. So what we would have to do with that is similar to what we had with our biome config, where we're going to have this setup. So I can just actually use this setup. So it's going to need to extract all of those textures. So post-processor textures. This is coming from our post-processing modifier. So we can add these in. We have retrieved those into the post-processor textures list. And actually what I could do is I actually could just, because I'm going to be doing the distinct, so I actually could just directly add them in. So this way it'll grab from the post-processing modifier. So we likely would have seen that it didn't end up adding in all of the layers, which if we'd been looking, we would have noticed that we didn't get any extra layers being created. Whereas now, if I run this, we now have all of the layers. So that was an important thing that we wanted to make sure we missed grabbing the post-processing one. So if you do add in anything like a pre-processing one, make sure you adjust that as well. But then now we get snow in higher locations. So we could do similar if we wanted to have water in low-lying locations. So we could set up a post-processing painter that what it does is in those low-lying areas, it textures stuff for water. So if it's going to do that, then what I would also have is I would copy that component and paste as new. And again, that process of having that giant plane is super handy for being able to work out a suitable height. So let's start at 30, which is where we know we're placing the snow. So we can drag down and see, okay, well, anything below 0, it's obviously not going to place any water. If we went for like 10, so 0 to 10 range, we would have a few pools of water there. What if we went for like a 15? So 15 feels like that might be a little bit too much. Maybe 12.5. 12.5 feels pretty good. So, okay, that gives us our ranges. So we know with the post-processing, we want it, I'm going to move this up here. So we want it to go from 0 to 12.5. Now this one, we want to actually invert this because we want the intensity to be most at near the starting point. So when it's near the ground. So we can just edit our keys here, change that to 1. Change that to 0, and then we can adjust our tangents here. So that looks good. Okay, so we've got that set up. Now we obviously need a texture for this. We don't want to be just using our snow texture. So what I can do is I'm going to rename this. So this is going to be water. Now with this texture, I want to edit that. So what I'm going to do is we will load this up in Photoshop and we'll just do a really quick tinting of the particular texture just to change its appearance. So that's cool. So this, we can pick kind of a darkish blue color for this layer. That works all right. We've got our texture in there for the water. And we can double check that our painter is, we can make sure it is linking to the water one. So it's got the water texture, so that's good. So we again regenerate our textures. And then again, we regenerate the world. And then what we should get is we should have snow in the mountains, we should have water in low-lying areas, and then we should have the rest of our texturing happening there as well. And then we could start to do things with that of, well, if we know water height is going to be a certain thing, we could start to texture stuff differently. So we didn't actually get any water textures appearing there. So we want to go and check that our scenes, so it does have the extra layers in there. Our terrain, if we take a look in terms of the painters, we do have the water set up. So we've got that correctly there. And we want to check our post-processing one. So it is starting at 0 and going to 12.5. And the intensity is falling off. Now we could adjust the way this curve is actually set up a little bit. So we could change the tangent here. So it's a bit of a steeper sort of fall off there. So we could try that. We'd probably also increase that end height there a little bit, seeing as we are tapering it off, just to make sure we've got enough range where we can see it. There is going to be probably a couple of little bits where it's maybe just starting to appear. And you also need to keep in mind it is blending in with the other textures as well. So when we are doing this, we're not changing other textures in that location. So it is going to be doing a blend with those textures. So if we use that, now because we're not adding in a new texture file, we can just directly go to regenerate the world. We don't need to regenerate the textures. So we'll let this run. And then what we'll do is we'll see how that looks. And we could potentially do stuff there in the painters where they actually suppress the other textures. So that's working better. So you can see we do get those appearing. Now, if we wanted them to do a little bit of suppression of the other textures, so we could have an animation curve, suppression, intensity. So we could then have more. I'm going to default that to false because I don't necessarily want that to be on for everything. And we only want to apply this within this range. But what I could be then saying as well, okay, well, F suppress other textures is on. So if we've got that turned on, now I'm not sure, is it 1 or 2 P's in there? I've managed to do both. It is 2. Much better. Okay, so suppressing other textures, if that is on, then what I would do is suppression, and then I would need to look up this value. So I would switch to storing this, and then this is going to be the height percentage. Just so I'm not recalculating it again and potentially making typos, things like that. So suppression, intensity, evaluate with this. And then what I would say is, okay, well, and I'm going to need to store the number of other alpha maps, which my smoothing was already doing the retrieving of that, so I can see how to do that. So int num alpha maps is my alpha maps get length 2. So I would go and say layer index 0, layer index is less than num alpha maps. If the layer index is equal to texture layer, then I do nothing. Otherwise, what I would do is, so there's different ways I could have this. I'd probably have it be a multiply, so it smoothly is able to bring the values down. And so it can multiply by the suppression. So if suppression of other textures is on, then update the other layers by suppression to other layers. So this will just give us a way of we can scale back things. It's not so bad for stuff like the snow, because that actually works fairly well. But for things like the water texture, because it's fairly dark, it's going to be fairly easily overwhelmed by the other ones. So in this case, the suppression curve is actually going to look pretty similar to my existing one. So I can actually select all and copy, and then go to here, and then I swore I was able to paste. Apparently, I'm not able to paste. Could have sworn. Okay, yes, you can, but you do it in the inspector. Cool. I thought I'd done it before. So I can regenerate the world, and this should then be doing some suppression of the textures there. And in particular in the deeper locations. So it should just mean water texture comes through with a little bit more intensity. So this could be something we could add into any of the modifiers if we wanted as well, just as a way to improve the visuals that are happening there. Now, because it's looping through all the layers, it does mean it is a slower process there. And it would help if I actually put layer index here. That is the danger of copying and pasting code, running into typos. So let's regenerate this again. We'll take a look. Did get a few little patches of water still, but this time around the water should come through a lot more clearly. And as you can see, it's a lot easier for configuring the textures and everything now. It's a lot less messing around. We're only going between our ProcGen manager, which we need to go to anyway, and the individual thing doing the painting. We're not then having to bounce between our biome config and our painter. Our biome config is controlling the high-level stuff, and our painters are just doing exactly the painting logic. There we go. So that ends up giving us a really nice sort of effect, actually. I really like that darker edge that it's adding. I actually think, because the suppression, that's right, I actually want this to be more like, I want it to be 0 at the start because it's scaling it, so it actually should be lower at the beginning. But I do really like that boundary sort of effect that it's giving there. It's one of the things, sometimes bugs will actually lead you to interesting potential changes you could make to stuff, because that visual effect, you can imagine if you had a texture here that's fairly bright and strongly emissive, you could make something that looks like there's a really sort of strange or alien or toxic sort of environment in the water there. So there's some really cool things you could actually do with it, especially with those really harshly defined boundaries that were coming through there. That actually came through really nicely. So with this, it's now actually nowhere near as cool looking. Gonna be honest, nowhere near as cool looking with that. It's still getting, we've got the nice intensities with the blue. We could change this curve a little bit, like in that case we were using an S1. Let's use one that doesn't ramp up quite as quickly and see how that looks. I actually think the first one kind of looked the best. Not entirely the effect we'd normally see with water, but it actually looked really cool. But we could use that same sort of process there, because we could have multiple ones to be texturing in shorelines. because we know where the water ends and we know where the other textures are going to then be kicking in. So we could do narrow bands. So you could do multiple things to generate the water. One that it's doing a really strong suppression of the textures from other layers, and doing that at a height range. And then you could blend that in with ones that are doing a lower suppression of ones. So there we go. That gives us, using that curve, gives us a much more intense one for the water in those areas. So we've got snow, we've got water, we've got our different modifiers. So just to kind of recap on the changes we were making here, we changed how we were storing the texture data. We removed it, so we weren't configuring textures on biomes anymore, because we're configuring them there only for use by the painters. So what we did was we switched things over so they're being set up on the painters. Did mean a bit of reworking of things, but it meant a reworking that speeds up and improves our workflow, where configuring textures is just done on the actual things using them, and we rely on the rest of the code having logic to avoid duplicates and things like that. So it's a much cleaner setup process there. We also set up some extra modifiers. So we added in with the some ones that can change things based on height, and can also suppress other textures. And we saw kind of the different effects that we can get with that. And we could combine those elements then for object placing. So our object placing could use stuff based on height. We could be, changing textures based upon proximity to the water as well. So using multiple rounds of these to really customize and control the kind of visual effects that we're getting with stuff. We could even modify things and do a final round of maybe some small height modifications based upon where we've placed particular textures and things like that. So that is all for the procedural generation based on biomes. As I said, grab the code, experiment with the code, see the kinds of things that you can create with it and make happen with it. And yeah, just dive in and experiment. Set up some, cool extra objects and see what you can do with it. Thanks, folks. If you're looking for the code for the project, then in the description below, you'll find a link to the GitHub. And on the GitHub, I've got the code for this project and for all of the other projects. They're freely available. And if you have found the video helpful and you'd like to support the channel, then throwing in a like or subscribing is always a huge help. If you're looking for further ways to support, then I do have a Patreon set up, and that's going to help me keep managing to do these videos for a long time to come, which is going to help more people make cool things. And that's awesome, because that's what this is all about, is helping more people make more cool things. And that is all. Thank you.